Okay, so we got this thing. Looks like this. Here's the box. So let's look at the forces on this box. We have force of gravity. Right? Force of gravity goes down like this. Pick that up. Okay, force of gravity. Then we got the normal force, perpendicular to the surface. Well, actually, we're not looking at the normal force yet. So let's just look at force of gravity. We want to look at the components of the force of gravity along the ramp and perpendicular to the ramp. So let's say this is the x-axis, and this is the y-axis. So that's the y-axis. So x extends like that. So this angle here, this is a right angle triangle. So this is 90 minus theta. And this is a right angle. So this angle in here is theta. That's the angle theta. Now we want the components of the force of gravity in the x direction and in the y direction. So let me get rid of this thing. So that's theta there. And this vector is the force of gravity. So the component along the y-axis is going to be Fg cos theta. The component along the x-axis is going to be Fg sine theta. You may just know that automatically because it makes an angle theta with the y-axis. That means the component in the y-axis is going to have the cos theta. And the component in the perpendicular axis is going to have the sine theta. So we could just write down Fgx is Fg sine theta. And Fgy is Fg cos theta. We could just write that down immediately. Now, if you don't know that right away, you could use trigonometry. So this is Fgx. This is Fgy. Now we could write, of course, the vector. So Fg equals Fgx plus Fgy. So a vector equation. So we're adding those two components to get our vector. And you look at this triangle, you could do Pythagorean theorem, trigonometry. So if we did over here, so sine theta is opposite over hypotenuse. So opposite is Fgx. Fgx, hypotenuse is Fg. So therefore, Fgx equals Fg sine theta. Then we could also do cos theta is adjacent over hypotenuse, which is Fgy over Fg. So Fgy equals Fg cos theta. So that's how we could get those components.